Last slide for this video. Again, we have this multiplication property of the 3 being shared with everybody there. So as we do that, 18 will get a cube number. Now I'm not going to immediately punch that into a calculator. I'm going to kind of try to be a little patient with that and see what I can do. Also, the 27 gets one. My 3 gets distributed by multiplication to the x. That will give me x to the 3/2. When my 3 gets distributed to the 2/3 by multiplication, 3 times 2/3 is 6/3, which reduces to a regular 2. Downstairs, 3/1 times 3/4 gives me a 9/4 power. And now here's a property I can use something here to my advantage, right? 18/27. I can actually write this fraction of two things cubed as a single fraction cubed. And notice there is a relationship between 18 and 27. In lowest terms, if you divide each by 9, that actually can be rewritten as 2/3. So 2/3 cubed looks a lot more manageable than the original 18 and the 27. So I'm going to be replacing those two numbers in my fraction with, let's see, 2 cubed is 8 and 3 cubed is 27. That's a much nicer lowest terms value there. My x, as I look back up top, my x has nothing with which to combine, so I will simply rewrite what's there. Now my y's, as you look, this is a case where I'd be doing some subtracting potentially. So I have to think about what is 2 take away 9/4. And to do that a bit more efficiently, I might want to think of my number 2 as a fraction in fourths. So if I would subtract this, I would get 8/4 take away 9/4. That would leave me y to the negative 1/4 on top. But that's not a good place to put a value. We don't want to have it negative. So if I shift it to the bottom, that which was negative becomes positive, and I have a better looking answer here for problem 9. For problem 10, that looks familiar. To rationalize my denominator, I have to do a multiply by to get groups of 3. Notice my 4 already has 2 groups of 2, so I can kind of back it down and use a smaller number. I already have 2 x's. I need groups of 3. If I multiply this by one more x, I will end up getting cube root of 8x cubed, which simplifies nicely to 2x. This looks just like a problem we did earlier. So that's my denominator fix. Once again, my numerator, I have to multiply by the same thing, so I'm not changing the value of this fraction. And if I combine that numerator, let's see, that will be cube root of 4x. And since my numerator and denominator here, I have a cube root of x above and an x to the basically first power below. Those are not matchable or cancelable. I do have a rational denominator. I'm happy with that as an answer. Here we will end the first part of the video. I will do the back page where we're multiplying by conjugates to do a similar thing to rationalizing the denominator. We'll handle that as a separate video. Thanks, good luck.